Hi guys, I hope that you're all doing well. Today's lesson is about perpendicular lines. Remember, we did parallel lines in the previous lesson. So perpendicular lines are two or more lines that intersect. To intersect means to cross each other at exactly 90 degrees. When two lines are perpendicular, they form a perfect T shape. Let's say we have this and that. That is a perfect T shape. Or they form a cross shape. You might have that line as well as that one. Okay, so to show the relationship between two lines, we use this symbol to show that those lines are perpendicular. For example, if you have, let's say this is line A and that is line B, if you want to show that they are perpendicular, you'll say A is perpendicular to B. So again, if you have this cross shape here and line A and B are perpendicular, so that means there you have your 90 degrees, you also have your 90 degrees there. So in the previous lesson, I taught you guys parallel lines, and I told you that you should always remember that parallel lines have the same gradient. With perpendicular lines, what you should always remember, basically the key property is that if two lines meet at 90 degrees, multiplying their gradients will always be equal to -1. For example, let's say we have the gradient of A, line AB, and line CD. Okay, when you multiply their gradients, let's say AB times CD, you always get a -1. Let's try the first example. We have proved that line AB passing through points A and B is perpendicular to line CD passing through points you have C and D. Before you even attempt this, remember I told you guys that when you multiply the gradients of perpendicular lines, you always get a -1. Remember this. As much as I emphasized on remembering that parallel lines have the same gradient, remember that when you multiply the gradients of perpendicular lines, you should always get a -1. Okay, so what's the first step here? Firstly, we have to find the gradients. We have point A and B. Let's write down our points. We have A, which is -2 and 1. We also have B, which is 2 and 3. So let's label this as point 1, that is point 2. -2 is your x and 1 is your y. 2 is your x and 3 is your y. This is x1, y1, x2, y2. Do you still remember the gradient formula? It's m is equal to y2 minus y1 all over x2 minus x1. Now let's substitute. We're finding the gradient of AB. Make sure that you specify this here. What is our y2? Y2 is 3 minus y1, which is 1. All over, you have x2, which is 2, minus x1, which is -2. Okay, now when you punch this in a calculator, you should get a 1 over 2, a half as your answer. So the gradient of line AB is equal to 1 over 2. So we have the gradient of line AB. Now let's find the gradient of CD. And remember, when you multiply these at the end and we get a -1, that means these two lines are perpendicular. We have to prove this. We have line CD. C is 1 and 4. D is 3 and 0. So that can be our first point, and that is your second point. 1 is your x, 4 is your y, 3 is your x, and 0 is your y. So these are under point 1, so that is x1, y1, x2, y2. Now let's substitute into our gradient formula. Remember, it's m is equal to y2 minus y1 over x2 minus x1. So the gradient of CD is y2, which is 0, minus y1, which is 4, all over x2, which is 3, minus x1, which is 1. When you punch this in your calculator, your answer should be negative 2. So we can write our gradient here. MCD is, at first we got 1 over 2 as the gradient of AB. The gradient of CD is negative 2. So remember that we have to multiply our two gradients, and hopefully we get a negative 1 so that we can prove this. The work that I did calculating the gradients has to be featured in your classwork book or your exams. So this is the gradient of AB times the gradient of CD. The gradient of AB is 1 over 2 times the gradient of CD, which is negative 1. We can put this in a bracket. 1 over 2 times negative 2 is negative 1. Therefore, we can say MAB times MCD is equal to negative 1. Therefore, AB is perpendicular to CD. You've proven this. Remember, you always have to get a negative 1 in order to prove that these lines are perpendicular. If you didn't get a negative 1, that means they are not perpendicular. Before I move to the second example, there's something that I want to show you guys. A quick trick is to remember that one gradient is the negative reciprocal of the other. Okay, meaning with reciprocals, you know that if you have, let's say, 1 over 2, the reciprocal of this is the 2 goes to your numerator and the 1 goes to the denominator. We flip them. This will be 2 over 1, which is 2. And if you have, let's say, 3 over 4, the reciprocal would be 4 over 3. And if you have, let's say, A over B, the reciprocal will be B over A. So if we have, let's say, 2 over 3, the negative reciprocal of this will be negative. This 3 goes to the top and the 2 goes to your denominator. So if you multiply 2 over 3 times, in a bracket, negative 3 over 2, you will get a negative 1. So I'll write this for you guys in the description. Remember that one gradient is the negative reciprocal of the other. So I did the first example. The first variation in which they'll ask you about perpendicular lines is to prove that they are perpendicular, and you know that you have to find the gradients and then multiply the gradients. Let's try the second variation where you have a missing variable. This video was probably brought to you by Kooks. Looking for fresh, delicious home-cooked meals made with care? Kooks has you covered. Whether you're ordering for one person, a couple, a small group, or even a huge event, they prepare mouth-watering meals that are packed with flavor and made to satisfy. The menu includes tasty options like Greek yogurt berry bowls, egg with roasted veggies, chicken and navel wraps, and so much more. Perfect for lunch, dinner, events, celebrations, or simply treating yourself to a quality homemade meal. To receive the full menu or to place an order, contact them via email at kamokooks@gmail.com. The second way, line AB has a gradient of 3. Line CD is perpendicular to AB and passes through point 0 and 2. Find the equation of line CD. First step, I said perpendicular gradient, negative reciprocal. What we have to do is find the perpendicular gradient. Because the lines are perpendicular, meaning AB is perpendicular to CD. Remember, I said that when you multiply the gradient of AB with the gradient of CD, you should always get a negative 1. So if the gradient is 3, okay, the gradient of AB, if it's equal to 3, then that means the gradient of CD is the negative reciprocal. Remember, I told you that if you have 2 over 3, the negative reciprocal is a negative, then 3 over 2. So for 3, it has to be negative 1 over 3. And why is that? Remember, when you have a whole number, there's always an over 1 that we never write. So this is, when you find the reciprocal of this, the negative reciprocal, we start with a negative sign. Then this 1 goes to your numerator. There's your 1 over. That 3 goes to your denominator, which is 3. So it's negative 1 over 3. With perpendicular lines, remember that when you multiply them, you always get a negative 1. But again, when you have one line, when you have the gradient of one line, the other gradient is the negative reciprocal. So remember those two things. I'll mention this at the end of the video. So we now have our gradient for line CD, so you can write this as the gradient of CD is equal to negative 1 over 3. Okay, we're done with the first step. Let's move to step 2, substitute gradient into equation. Now, why did I mention the equation? Find the equation of line CD. Okay, which formula do you think we should use? The straight line formula, because I mentioned it at the beginning of the video, which is y is equal to mx plus c. Now let's substitute this into our formula, that gradient that we calculated. This will be y is equal to negative 1 over 3 plus c. Now you guys are definitely familiar with this part. How do we solve this? We can plug in this point, okay, because it passes through CD. You always want to find a point that is related to the equation that you're solving. So we have point 0 and 2. Now let's substitute these points into our formula. Remember, this is your x and that is your y. So when we see y, we have to substitute 2. This will be 2 because it's y is equal to negative 1 over 3. Excuse me, there should be an x there. Negative 1 over 3 x, which is 0, plus c. Now let's solve for c. We have 2 is equal to negative 1 over 3 times 0 is 0 plus c. So this will be 2 is equal to 0 plus c, so obviously c, therefore c is equal to 2. Now let's write down our final equation, which is y is equal to, we have m, our gradient is negative 1 over 3. Negative 1 over 3 x plus c. What is your c? It's 2. So you've solved this equation. Now let's do a quick recap. What you should have in your notes is this information about perpendicular lines. Okay, firstly, perpendicular lines meet at a 90-degree angle. When you multiply the gradients of two perpendicular lines, you always get a negative 1. Remember that this is the symbol that we use to show that two lines are perpendicular. What else? There are two ways in which they'll ask us about perpendicular lines, in grade 12. Firstly, we'll have to prove that AB is parallel to CD. It doesn't have to be AB and CD. It could be just any lines, but just know that you'll have to prove that two lines are perpendicular. And secondly, you have to find the missing variable to find the equation. And that is all under perpendicular lines in grade 10. If there are more variations or different ways, I'm certain that we'll meet them in the different question papers that we'll do together. Thank you guys for watching. Please like and subscribe. I'll see you in the next video.